All right, so we're nearing the end of our discussion about logarithms. We're building to the point where we'll be able to solve logarithmic equations and then use those to basically solve word problems that involve exponential functions and logarithms. So in order to do that, we need to learn about logarithmic properties. Specifically, we're going to learn what are called the product rule for logs, the quotient rule, and the power rule. Okay, and honestly, you really only remember two of the three, but it's good to know all three. So we're going to practice these by expanding and condensing logarithmic equations, or expressions rather, and we're going to see where the change of base formula that we saw earlier comes from. So, all right, so when we want to simplify a log, we're thinking about what exponent should be placed on the base to give the number in the argument, right? That's what a log is all about. So here, so we say, you know, what's the log base 5 of 5 to the negative 3? Of course, we are going to say, well, we're going to say 5 to the what equals 5 to the negative 3. And we can just look at that one and say, well, obviously the bases are the same, so the powers have to be the same. So negative 3, right? What about log base 13 of 13? We know that's going to be 1, right? 13 to what power equals 13? Well, it's to the 1 power. Ln of e to the x, what is that going to be? We're going to say, well, e to the what power equals e to the x? We're going to say to the x power. Pretty easy there. What about log base q of q to the root 3? That's like crazy looking, right? So we're saying base to the what equals q base to the root 3. And we can tell right away now that we're looking at square root of 3. So these are mostly review, right? One last one, log base 10 of negative k. We're saying 10 to the what equals 10 to the negative k. And of course, we're going to get negative k out of that. But for each one of these, we kind of notice something, right? We have a log composed with its inverse function, right? We have log composed with the exponential, and so we see a property here, which we've already seen when we first talked about inverses, where we can say, oh, the inverse, f inverse, composed with f of x, just gives us x, right? So for any base b and any real number x, log base b of b to the x equals x. This is the same, this is the property, right? Because they are inverses, when you compose them together, you get whatever the initial input is, which in this case is x. Okay, so kind of the reverse, right? Same story, exponential functions and logs, they are inverses of each other so long as they have the same base and no other transformations, so they undo each other, right? So the same property as before, log base b of b to the x equals x, we can say, oh, well, let's compose them in the opposite order. Let's say b to the log base b of x, right? So this is like saying f of f inverse of x equals x, okay? So this makes it very easy here to say, well, what is 3 to the log base 3 of 7? I've got the same base, right? I've got the exponential with its inverse function in the exponent. This is just going to be 7, right? Whatever the input is. You can think of them as basically canceling each other out, the 3 to the x and the log base 3. It's not quite correct, but it works, right? So 10 to the log base 10 of x, that's going to be x. E to the ln of x cubed, right? So e and the ln of x, when you compose them together, they undo each other. We just get left with the initial input. And e to the ln 6 will be 6. Okay. So that is, well, that is almost a good place to pause, but let's do this quick proof here, right? So we're going to say, hey, I've got this log function, log base b of x. I'm going to call that m. All right, so that means by the definition of logarithm, right, that b to the m equals x, right? Okay, so that means b to the m would be b to the log base b of x. And we already know, oh look, that's equal to x, right? So there's a proof. It's very, very short. I wrote over it. I'm going to write this down a little bit further, right? So we would have b to the m would be b to the, what was m? Log base b of x. And we know b to the m is equal to x. So there's our proof. There's like nothing to it. All right, next video we'll talk about, I think, our product rule.